Hello everyone, this is Divya working as assistant professor in EEE department at St. Peter's Engineering College. So in the previous classes, in the previous videos, we discussed about what are the classifications of the control system and what is the definition of a control system and how we can obtain the mathematical modeling of a control system for the mechanical systems as well as for the electrical systems and and we completed the effects of feedback on control systems and we derived how we can obtain the transfer function from the block diagram reduction techniques. We discussed about various block diagram reduction techniques. By using those techniques, we obtained the transfer function and we discussed about the industrial control systems. So, coming to the next unit, that is time response analysis. So, in this session, I want to discuss about the time response analysis of the system. For that purpose, I have to show what are the contents here I want to discuss. So, what are the standard test signals we are considering and what is meant by time response? How many types of responses exist in the time response and how we can analyze the first order system and second order system. Okay, so I want to discuss about the standard test signals and what is the time response, what is the definition of the time response and types of the responses and the analysis of the first order system and analysis of the second order system. So initially we will go with various standard test signals. Those are first of all, I am explaining about the impulse signal. What is meant by impulse signal? If you observe the graph, you can see it as at all the other values of t except t is equal to 0, the output value is 0. At only t is equal to 0, the output is a. That means here you can represent it as the impulse signal can be represented with delta of t. That means that is the output and we are taking with respect to time period t. That means here I am considering the time t, right? So del of t is equal to a at only t is equal to 0. At all the remaining values of 0, we can represent it as t not equal to 0, that is 0, right? So here we can say it as 0. So here we are considering only at t is equal to 0 the output will be present. At remaining all values the output should be equal to 0. Then only we can say the signal as a impulse signal. So we have to represent the signal with del of t which is equal to a at t equal to 0 and that should be equal to 0 at t not equal to 0. If this a value is equal to 1, the impulse signal is called as a unit impulse signal. That means the impulse signal can be defined as the impulse signal imitate the sudden shock characteristic of the actual input signal. That means if there occurs any sudden characteristics due to the actual input signal, then that can be treated as a impulse signal. If this value is equal to 1, then we can say it as a impulse signal. That means unit impulse signal. We can say it as a unit impulse signal. When the value of a is equal to 1, then we can say it as a unit impulse signal. What is the definition of the impulse signal? Impulse signal imitate the sudden shock characteristics of the actual input signal. Okay, so and next coming to the next signal, that is step signal. Step signal is nothing but we are giving the input like a stepwise. That means from t is equal to before t equal to 0, the output is 0. After t equal to 0, the output will be some constant. That means we can represent it as always the step input is indicated with u of t. So we have to represent u of t is equal to a when t greater than or equal to 0. Here a indicates the magnitude of the step input. U of t is equal to a when t greater than or equal to 0 and u of t is equal to 0 when t less than 0. So a step signal can be called as it can be imitate the sudden change in the characteristics of a actual input signal for a long time when compared to the impulse signal, right? At impulse signal at only t equal to 0, the sudden change will appears and it will disappear at t greater than 0, right? But in the unit, in the step signal, a sudden change will appear due to the input signal and that will remain constant for some time. So this is nothing but the definition of a step signal. If this value, that means a value is equal to 1, then it can be called as a step signal. If the value of a is equal to 1, then it can be called as a step signal, unit step signal. And it can be defined as u of t is equal to a when t greater than or equal to 0 and u of t equal to 0 when t less than 0. So this is the description about the step signal. And next, coming to the ramp signal, all of you know how to draw the ramp signal, right? This is a linear wave, that means linear line which is passing through the horizon. That means this line will have some slope, right? So the ramp signal imitate the constant velocity characteristic of a actual input signal. This means here it consists some velocity which can follow constant velocity characteristics of the actual input signal is nothing but ramp signal. So we can represent the ramp signal with a quantity r. That means we can represent it as r of t with a time period t. So r of t is equal to a into t. A means here a represents the slope. With respect to slope, this is changing, right? So a is the constant value, t is a variable value. So we can represent r of t is equal to a into t at a t greater than 0. That means on the right side of this band. So r of t equal to 0 at a t less than 0. If a value is equal to 1 in this equation, then we can say it as a unit ramp signal. We can say it as a unit ramp signal. And next, coming to the parabolic signal, what is the equation of parabola in this direction? Mx square, right? So I am taking only half of the parabola, that is mx square by 2 in general. But here we have to consider t as the variable, right? And a as the slope. So I am taking at square by 2. So parabolic signal can be represented with the letter p. So here on y-axis I am considering the output as p of t. So at t greater than or equal to 0, the p of t value is equal to at square by 2, and at t less than 0, the p of t value is 0, right? So from this graph, how we can define the parabolic signal? A parabolic signal can imitate the constant acceleration value based on the characteristics of the actual input signal which is given to the system, right? That means here at square by 2 indicates which is nothing but acceleration. That means x square. That means the second order derivative is nothing but acceleration. We can consider it as dot t square, right? Dot t square divided by dot t square. So that means that is a second order function. The second order function is representing the acceleration, right? So here, if the value of a is equal to 1, then we can say it as a unit parabolic signal. If you substitute the value of a is equal to 1, then it can be obtained as a unit parabolic signal. Okay. And coming to the relation between these standard test signals, we can obtain the step signal by integrating the impulse signal, and we can obtain the ramp signal by integrating the step signal, and we can also obtain the parabolic signal by integrating the ramp signal. And in the opposite way, we can obtain the ramp signal by derivating the parabolic signal, and we can obtain the step signal by derivating the ramp signal, and also we can obtain the impulse signal by derivating the step signal. How we can obtain it? Once analyze it. What is the parabolic signal equation at t greater than or equal to 0? That is p of t into at square by 2, right? That means if you are derivating this equation with respect to t, what will be the output? Here a and 2 are constant. A is the slope and 2 is a constant. So I am taking it outside. D by dt of t square is nothing but 2t. Here 2 and 2 will cancel. And what is the output here? At. So here I obtained the ramp signal. So what it indicates? By derivating the parabolic signal, we are able to obtain the ramp signal. So in the same way, if I am derivating the ramp signal, that means d by dt of at, then what is the output here? A is a constant, right? So I can write it as a into d by dt of t. So A into 1, what it indicates? A into 1 is nothing but that is A, right? So here by derivating the ramp signal, I'm able to obtain the step signal. Is it right? So by derivating the step signal, what I am able to obtain at t greater than 0, d by dt of constant is nothing but 0, right? So by derivating the step signal, I'm able to obtain the impulse signal. So this is the relation between the standard test signals. So in the same way, by integrating also, we are able to obtain step by integrating the impulse, and we are able to obtain the ramp signal by integrating the step signal, and we are able to obtain the parabolic signal by integrating the ramp signal. For example, here, see here, what is the integration of A into t dt? Here time period is the variable one, time is the varying quantity, so I am taking dt, right? So the integral of at dt, which is nothing but a is constant here, a into integral of t dt, right? Integral of x dx formula is, or else integral of x power n dx formula is x power n plus 1 by n plus 1. Here in the place of x you are having t, and in the place of n you are having the number 1. So what is the formula? A into t power n plus 1 by n plus 1, right? So in the place of n substitute 1, that means a into t power 1 plus 1 divided by 1 plus 1, that means at square divided by 2, right? So this is the obtaining the parabolic signal by integrating the ramp signal, right? We can obtain the parabolic signal by integrating the ramp signal in the same way about 2 also. Okay. And next, coming to what is meant by time response. In general, what is meant by time response? The variation of time period for a particular system for the analysis purpose is nothing but time response. So we can say it as, in time domain analysis, time is the independent variable. Is it right? Time does not depends on any quantity. It is a independent variable, right? So when a system is given a excitation, that means when you are providing a input to a system, then there exists a output. That means a response will be obtained by the system. So that response varies with respect to time, and that is called as the time response. That means I'm having a particular system. If I am giving some input to the system, then the output will be occurring from it. The output is not a constant value initially. There exist some variations. All the variations and the constant values, all this comes under the output, right? The output is nothing but the response. So the variation in the response with respect to time is nothing but the time response of the system. So it can be called as the variation in the response of the system with respect to time is called as time response. Okay. And coming to the types of time response, there exist two types of time responses. We classified it into generally two types. Those are transient response and steady state response. What are those? Transient response and steady state response. So coming to the first one, that is transient response. A system takes a certain time to achieve its final value. So that final value is nothing but the transient response. For example, if I want to obtain an output of 5 volts, but initially I am not instantly obtaining 5 volts output from a circuit. So what will happen from 0 to 5? Slowly it will increase. After a particular time limit only, I am able to find the output is 5 volts, right? So the time period before achieving the final output is nothing but the transient response. So how we will define the transient response? The variation of output response during the time which it takes to reach its final value is nothing but transient response, right? Now only I explain. I want to obtain a final value. For example, I am considering it as 5 volts. Before reaching 5 volts, it will reach to 1 volt, 2 volt, 3 volt, 4 volt, and then it will reach us to 5 volts, right? So to reach 5 volts, there exists some time gap between the initial value and the final value, right? So that time period to reach its final value is called as transient response of the system. So the time period requires to reach its final value is called as transient period. and mathematically it can be expressed as shown here. The limit t tends to 0, Ct of t is equal to 0. That is the representation of transient response by using the mathematical expression. What is meant by transient response? The time required to reach its final value of a system is nothing but transient response of a system, and the time period required to reach its final value is called as transient period. Okay, and here see the example. So here, for example, if a person is moving from ground floor to first floor, he has to reach the first floor basically, but without following the steps he is not able to reach the first floor, right? So he has to take some time to reach the first floor. So initially he is at ground floor, and after that he is reaching half of the floor by using the steps, and after that he is reaching its final destination. So here this is the total time which he is used to reach his final destination, right? So this time is called as transient response. Okay, clear? This is called as transient response. And coming to the transient response, we are able to know by using this transient response, we are able to know when the system is begin to respond after an input is given, and how much time it takes to reach the output for the first time, and whether the output shoots beyond the desired value and how much it shoots, that can we know, and whether the output oscillates about its final value or not, this will also we can observe, and when does it will settle on the final value. So all these things are we can able to determine by using the transient response, by determining the transient response. And coming to the second one, that is the steady state response. So what is meant by steady state response? So steady state response is nothing but it is the final value which is achieved by the system output. That means previously I said I want to achieve 5 volts output. So that is my final value, right? So basically the final value achieved by the system output is nothing but the steady state response. So the steady state response starts after the transient response only. That means after completing the transient response only in a system there exists a steady state response. That means it will, the transient response will completely dies out. After that only the steady state response will start. So how we can define the steady state response? The part of the response that remains after the transient which have dies, so it is called as steady state response. That means the part which remains constant in the response of a system after dying the transient response, that part is called as steady state response. So this is the definition of the steady state response. So from this steady state response, what are the elements we are able to know? Now discuss that one. So how long it took before the steady state the output is reaching, and whether there is any error between the desired and the actual outputs. For example, if I want to achieve a 10 amperes current by using a system, but I am able to achieving a 9 amperes current by using the system, then we are able to determine what is the error for the desired output and each for our aimed output. We are able to know what is the difference between the desired output and the actual values, right? That is called as error. And we are also able to know is the error is constant, zero or infinite, or else it is varying. We are able to know that one also by using the steady state error, that steady state response. Okay, and see here, if the time increases, what will happen? The response of the system also increases slowly at a particular value. That means consider it as 15. At this particular value, this response is maintaining as constant. That means after this line, this can be indicated as a steady state response. And before this line, we can say it as a transient response. What I am doing here? I am applying a step input signal for a control system. So when I am giving an input as 5 volts, what will happen here? The output suddenly does not rise at a time, right? So it increases slowly up to a particular value up to 15 seconds. After 15 seconds only, the output remains constant. So before 15 seconds, that means from this 0 to 15 seconds, I can say it as a transient response state. And from 15 seconds to 20 seconds, I can say it as a steady state response state, right? So this is the difference between transient response and steady state response. In the transient response, the output is not constant, but in the steady state response we are achieving the final output. That is the basic difference between transient response and steady state response. Okay,